This is the second video of Unit 2, and last time I talked about the periodic table. I did mention the noble gases found over here on the far right side of the periodic table, starting with helium, and generally think of radon being the last one. This number 118, there might be some discussion amongst chemists as to whether it actually exists. Many of these elements, these upper elements, when you get past 107, 108, it's just by mathematical calculations that they've existed for a fraction of a second. So it's not as if they can actually produce an element and show it to you. Everything beyond uranium is human-made. But the helium going on down through radon, they all have full outer shells. Helium has 2 electrons in its outermost shell. Neon, argon, krypton, xenon, and radon all have 8 electrons in their outermost shell. I don't distinguish between compounds and molecules, and I found over the years that texts that write about them don't do a very good job of distinguishing between them, so I just consider them pretty much the same thing. A compound or molecule for this class will be 2 or more atoms that are joined together, chemically bonded together. And that brings up, what is an atom? An atom is the smallest part of an element that still retains the characteristics of that element. Also, an atom would be made up of a nucleus and an electron cloud. I do have a URL listed here that if you wanted to go and watch this URL, it has some information about the atom that seems to be fairly accurate. The URL is http://www.youtube.com/watch?v equals, looks like an L, capital P, 57 G, capital E, capital W, CIS, capital Y, ampersand, the word feature, equals related. Hopefully that'll get you there. The nucleus is the central portion of the atom, and it will have a minimum of 1 proton. Hydrogen has a proton in it, and its atomic number is 1, so all hydrogen atoms have 1 proton in their nucleus. The proton has a positive charge, and its mass is also significant. When you are calculating masses or weights of atoms, the mass of the protons becomes an integral part of that calculation. Also in the nucleus, most atoms, not all, but most atoms will have a neutron or neutrons. Most hydrogen atoms do not have a neutron. There are a very small percentage of atoms that will have 1 neutron, and an even smaller percentage that have 2 neutrons. The neutron has a mass that is just slightly more than the proton. It has a neutral charge. Some describe it as having no charge. So its charge is not significant, but its mass is. So when you calculate masses of atoms, or the mass of an atom, the protons and the neutrons are what are important. Because the protons are positively charged, the nucleus, which contains both these types of particles, has an overall positive charge. As I mentioned the atomic number in the past, the atomic number is the number of protons that's found in an atom. And all the atoms of a given element have the same number of protons. So all hydrogen atoms have 1 proton in their nucleus. All helium atoms have 2 protons in their nucleus, and so on. The atomic weight or mass number, different ways of describing it, it's a little bit different. But for our purposes, we round this to a whole number, and this would be the mass of the protons and neutrons added together. So if you're given the atomic number of an element, and you knew the atomic weight or mass, you'd be able to calculate in the average atom how many protons there are and how many neutrons there are. The isotope. I include the isotope discussion here because there are different isotopes for a given element on some of the elements. And what this means is different atoms of a given element having different numbers of neutrons in their nucleus form what are called isotopes. Iso having to do with the same element, but just different kinds of atoms, different kinds of nucleuses as far as the weight of those nucleus of the each nucleus in those atoms. Hydrogen would be a good example. I think I mentioned it later on. Maybe I don't. I do. Okay. I'll come back and touch on that more a little bit later on. The electrons are found spinning at very high speeds around the nucleus, and they form what's called an electron cloud. And one of the best ways I can describe the electron cloud is at any given instant, the electron cloud is mostly empty space, and the atom, therefore, is mostly empty space. The electrons have a negative charge. They have very little mass, but they have a tremendous amount of speed, and they give space or volume to the atom. And this electron cloud gives volume to the atom because it's made up of the electrons spinning around the nucleus. So at any given instant, if you could just stop the electrons, the electron cloud would be mostly empty space and the nucleus would be mostly empty space. The electron cloud, because of the speed of the electrons, it's described as a cloud. With the most powerful electron microscopes, scientists have taken images of large atoms, such as the uranium atom. But what you see is mostly a blur. It's because of the speed of the electrons moving around in the electron cloud. A little bit like an airplane blade, the prop. If you consider most single-engine airplanes, small airplanes have a two-prop system. Some have three, some have as many as five. At any given instant, the area, the space where the props are turning is mostly empty, but you wouldn't think about putting your hand in any part of that space because you understand in your mind that space is taken up by the propeller that's moving around. So it is with the electrons, they just take up that space. Some scientists describe the electrons as occurring in shells. This is just another way of understanding, and there are different explanations. It's not that one is correct and the others are incorrect, it's just different perspectives of how those electrons occur and where they occur in the atom. The electron shells go along with the periods of the periodic table. So when we were looking earlier at the hydrogen, see if I can get it pulled up here. Notice that the hydrogen is way over here on the far left as the atomic number 1, helium way over on the far right, atomic number 2. That tells you a hydrogen atom generally has 1 electron, helium atom has 2 electrons. That helium atom has a full first outer shell, only 2 electrons can fit in the first shell. Then you go to the second shell. This corresponds to the second period of the periodic table. Lithium would have 1 electron in its outer shell, 3 total. Notice it's in the first column. That's 1 in its outer shell. The little 3 there tells you there are 3 total. Beryllium has 4 electrons total, 2 in its outermost shell, and so on. Valence electrons are those electrons that are in the outermost shell. So hydrogen has 1 in its outermost shell because it only has 1. Helium has 2. The beryllium that I mentioned has 2 valence electrons. Even though it has 4 total, it has 2. And it's the valence electrons that determine if and how an atom will react with another atom. If it has a full outer shell, it tends to not want to react. It tends to be more stable. because of those valence electrons, that determines what kind of chemical bonds an atom will form with other atoms. And the first one I have listed here are ionic bonds. What happens with some elements, some atoms? A metal will tend to give up an electron or electrons, and a nonmetal, such as fluorine, oxygen, or chlorine, will tend to take on an electron or electrons. When they do that, they take on a charge. Because electrons are negatively charged, the nonmetals will tend to become negatively charged, and the metals will tend to take on a positive charge. Sodium chloride is a good example. Sodium tends to become positive, and the chloride becomes negative. In chemistry and physics, and biology thereby, it's understood that opposite charges attract, and those opposite charges that are attracting form ionic bonds. So sodium and chlorine will bond to each other in what's called an ionic bond. Covalent bonds, you think of together, valent, having to do with the outer shell electrons. Covalent bonds are those bonds that are formed by the sharing of electrons and the sharing of outer shell electrons. It may be that one electron is shared from each atom, maybe two. In some cases, in the case of nitrogen, there are 3 electrons from each atom that are shared. And depending on how many pairs of electrons are being shared between 2 atoms, determines what kind of bonds, what type of covalent bond is formed. If it's just a single pair of electrons, it's a single bond. If it's 2 pairs of electrons, it's a double bond. And an example of a double bond would be oxygen. 2 pairs of electrons are being shared in that case. Same would be true of sulfur bonding with itself. Triple bonds, nitrogen gas is a good example. When nitrogen bonds with itself, it forms triple bonds. And triple bonds are stronger than double bonds, which are stronger than single bonds. Hydrogen bonds are a little bit different. They are not due to the transfer or the sharing of electrons. Hydrogen bonds are weaker than ionic bonds or covalent bonds, and they're formed by attractions between atoms on different molecules. And it's oftentimes between a hydrogen and oxygen. Hydrogen tends to become somewhat positive, and the oxygen tends to become somewhat negative, and that opposite charge helps them to attract to each other. Heat is a type of kinetic energy that can be transferred from one substance to another, generally from one that has a higher temperature to one that has a lower temperature. Temperature is a means of measuring the amount of heat, and in a sense you're measuring the amount of kinetic energy. If you think about a mercury thermometer or an alcohol thermometer, you'll notice that as you put more heat into that thermometer, the liquid that's measuring the temperature moves. It's because there's more energy in those chemicals. They're hitting each other faster, and they spread out and expand. And that's generally true of things. You put heat into them, and the atoms and the molecules become more active, and they tend to expand. In the next video, I'll try to talk a little bit about water, and that'll be video number 3.